Okay, so solving equations using a graphing utility, i.e. graphing calculator. Once again, if you have your phone, if you don't have a graphing calculator, you can use your phone and do Desmos on this today. I actually did Desmos for the notes, but that's because it made it really easy to cut out a picture of the graph and paste it up on the screen. That's the only reason I really did that. Your first step to do it when you're solving it graphically, set the equation equal to 0. If it's not equal to 0, you want to make it equal to 0. Okay, that's what you want to do. You want to make it equal to 0. If it's not, do so. That's your first step. And then graph y equals f of x, find the x-intercepts. Now, you can kind of ignore this, like I said, the paper I gave you. And I have that paper posted online. Okay, it's one of those ones I try to post everything online. I have that posted online. So if you lose this, it is available, and it's the same thing you have there. How to solve graphically, step-by-step, how to do that. Okay, so if you lose the handout that I give you to be in class, I will have extras, but I have it online, so you can always look it up online at any time. Bless you. Okay. So let's take a look at the first set of problems. So a couple of basic polynomials. How are we going to solve them? So I have x to the 4th. It could, remember we talked about this, x to the 4th. It'll look like a parabola, kind of, with squiggly stuff in the middle. Okay, I could have 4, 3, 2, 1, or 0 solutions, depending upon how many times it crosses and or touches the graph. I don't know. I don't know off the top of my head, but those are my possibilities. I could have no solutions because if it goes up both ways, it might possibly never come down and do that. So here's what I want you to do. Get out your graphing calculator. Do that first one.
What?
Yeah, I did. I did it on my calculator. I did it online. That's what we're doing today. We're practicing these and getting them down. No. We have a lot of these we're going to do. So I do want to talk about this. Here's the first one. -1, 0, 2, 0. Now, a couple of things. Some confusion. If you read the instructions, particularly for the TI, because the Casio doesn't like this for you. The Casio automatically finds the roots. You don't have to look for them. For the TI, the instructions say when you hit root, you have to move the cursor to a particular spot to the left of where you think the 0 is. Not on the 0. It has to be to the left, the x-coordinate to the left of the 0. You hit enter. That establishes your left bound. You move the cursor over till it's the other side. That establishes your right bound. You hit enter again, and your calculator zeroes in on the 0. Here's what it does. It's actually using, I forgot there's a particular theorem in calculus that we teach in calculus that talks about this. But here's the deal. You have, in this particular case, you have a positive y value and a negative y value. It starts putting in x coordinates and narrowing in until it hits 0. Because when you go from net positive to negative, what do you have to have in between? You have to have a 0. If it is continuous, you have to hit 0 in between. What you're doing is you're guessing one side of the 0, you're guessing the other side of the 0, and the calculator plugs in x coordinates till it zooms in and gets 0 for y.
Nice.
That's what it's doing, and then it tells you where that x coordinate is. That's what you have to do. Put the cursor here, hit enter, and then the cursor will pop up, move it here, hit enter again, it will tell you where the 0 is. And then you have to do it all over again for this one to get the other side. Okay, you have to repeat those same 3 or 4 steps to get to this one. It will not automatically give you all of them. Okay. This is one of the problems I have with the TI is because it's forever to do this. Okay. This is also how the solver menu works. If you went to the solver and used the solver rather than graphing, it would guess one answer. It would only give you one of those. And if you did not know how many zeros you had, it would say, oh, here's my 0. But you might have more. That's where the graphing is nice because I know how many zeros I have in a particular window. Those are the zeros I have in the window. If you don't have the graph, you don't know which one it's giving you, where it's at, or anything like that. And then you have to guess another point, and you have to change the bounds, and then it does the same thing. It goes like this until it hits 0 in between. That's what it does. Okay. Or what I've seen it does on the solver, what it does is you pick a point, it starts there, and then it moves out until the sign changes. Go, oh, there's a 0 between here, and then I'll 0 in on this one. So let's say it hits the 0 here first before the 0 on that side. It's going to say, here's your 0, and it's going to ignore that one over there. Okay, that's one of the things I don't like about the solver menu. And the Casio does the solver that way too, except for polynomials. You can type in the coefficients of the polynomial, and it will give you all the real solutions for polynomial. Right? So that's what you're doing on that. Yes.
How many decimal places?
Good question. That was the other question I wanted to be recording when I addressed it. We are going to use standard AP rule for decimals in here. Standard rule for AP is 3 decimal places, truncated or rounded. Truncated means you go to 3 and you cut it off. Doesn't matter what it is. Or you can round it. So sometimes there's one answer, because rounded and truncated would be the same. So for like 0.241, 241, let's say 6, or 24123, truncated, rounded, the same thing, right? It would be here. This would be your answer. Now, if I have 0.3517, truncated would be 0.351, rounded would be 0.352. Either one of those is good. AP calculus rules, 3 decimal places, truncated or rounded. If you go more than 3, that's fine with me. Now, if you have an exact answer like these two, your answers are -1 and 2, just put -1 and 2. Do not put -1.000. Because it's implied that it's all zeros afterwards if you don't have that when it's a whole number like this. You don't put it down, and we're going to 3 decimal places. So you don't have to put 0.000. Okay, if your answer is 3 decimal places or less, you just put the same answer you got. But if it's more than 3 decimal places, it's either rounded or truncated. So it'll be 3 decimal places. And that's the minimum. You can always go more. Okay, you can be more accurate. Instead of being Chevy, you can be NASA. I'm okay with that. Right? What's the difference between the Chevy pickup and a NASA satellite? Decimal places, which is accuracy. Because if your Chevy pickup breaks down, it's not a problem. No big deal. Pull off on the side of the road. If your NASA $3 billion NASA satellite breaks down in the middle of space or on the way to Mars, you're screwed. And there's $3 billion down the planet.
Satellite only has a point, though.
Yeah. Depends. Okay. If you have not already, do number 2.
What?
A lot of people are already starting to move on, so let's take a look at this one real quick. You get -1.43 and 1.164.
Yeah.
Okay. Now, when you get to this one here, what do you need to do first? Set it equal to 0 first. Now, there is a way to do it without setting it equal to 0. It really sucks. What you do is you graph this side, graph that side, where the 2 graphs cross each other, which on Desmos is easy, but on your calculators is a really, really hard thing to do. So what you want to do is set it equal to 0. Doesn't matter which way you go, you're still going to get the same thing in the end for as far as answers go. Even if you have even if you move the x to the 5th over here and have a negative x to the 5th, or move it over here and make it positive, it does not matter. You will still get the same zeros. The graph will be inverted, but you will still get the same zeros. You don't really care about the graph here. You're just trying to find the zeros. Okay? Same thing on that one. Set it equal to 0. Don't screw with the absolute value, or you can, kind of a pain, I would move the other one, but you can also move the absolute value over to the other side as a full unit. Okay. On your TIs, many of the TIs, I don't know if they've removed it or if it's still there, there is a vertical line. There's a key that's a vertical line. That is not absolute value. That key that has a vertical line and, ooh, looks like that's an absolute value bar. I'll put that one down, type in the stuff, put it down again. That is not absolute value. I think they've removed it from a lot of the newer ones because it was confusing. To do absolute value on both the TI and the Casio, you have to type in ABS, parentheses, parentheses, and everything in between. You're taking the absolute value. Yeah, it's kind of a pain.
Okay, so if I did like mode, that is going to what is CMOS?
Okay, when you set it equal to 0, what'd you do? Did you move the 3x to the 4th and the x, and did you make them both negative? If only one of them was positive, if one of them was negative and one of them was positive when you moved it over, you made a mistake. Or if you just put it on the other side, that may be part of the problem. For number 3. Now you set it equal to 0 can be a thing. Now I like isn't that cool? That's what absolute values do. Absolute value functions do goofy crap like that. You have a point in them somehow. Okay? If it's just the absolute value function, but if it didn't have the rest of it and only had this, it would be a parabola, but everything that would normally be below would be above. Come down, it would come down and touch and then go up, and then you'd have this really funky thing. Absolute values, you see something like that, that is one of the things that absolute values will do. That's why it has that funky shape to it. Okay. So this one, once again, set it equal to 0 before you put it in there. The other thing you need to do is when you type it in, make sure your denominator has parentheses around it, because if you don't, you will have problems.
It'll look like that.
Okay. If you say 2 divided by x plus 2, it'll take 2 divided by x and then add 2 to that whole thing. If you don't put parentheses around the x plus 2, your calculator will think you're only dividing the 2 by x. You're not dividing 2 by x plus 2. You have to be explicitly clear in how you type things in. And you have to put parentheses around whatever. Okay? So you have to be explicit on that. The other thing is with a function like this, you have to be aware of where is it undefined at? Where do you have asymptotes? Okay, because that'll come in on your graphing when you do your graphing on this stuff. Okay. Quiet. In the interest of time, you can finish these up on your own. I'll make sure that everything's up there that you need to see. Okay, so on this first one here, you only have 2 zeros. Now, I put in 2 vertical lines. Those are the asymptotes. I have one at -2 because it's undefined at -2 to make the denominator 0. We're not allowed to do that. And at +1. I added those in just for visual reference. That's what's going on here. So your graph comes down. It does this one, and it never crosses on this one as it goes out. So you have 2 solutions at -4 and -1/8. Or where your 2 zeros are at. 0.125 is 1/8. Okay. Now, on the next one, this is kind of an important note to put in there, because this is a big deal. Whenever you have a function over a function, you have a rational function, which is a function divided by a function. Wherever the numerator is 0, you have 0. Wherever your denominator is 0, it's undefined. Sometimes that's an asymptote, sometimes there's other goofy crap going on. Depends on what's happening. If it's 0 in both the numerator and the denominator at the same place, it's undefined. Undefined, it trumps being 0. 0 over 0 is not 1. 0 over 0 is undefined, because anytime you have 0 in the denominator, irregardless of what's in the numerator, it's undefined. Okay? So in this one here, I don't actually have to find the zeros, I don't actually have to graph this thing and do it. I can just figure out what my answer is from the polynomial. I can just solve that quadratic and I've got my zeros. Because my zeros are strictly from the numerator. My denominator will give me undefined places, but my numerator are where my zeros are at. Okay. -1 and +1/2. And I don't have it on here, but the zeros for the denominator are actually between these. That's where the asymptotes are. I didn't put them on there because they're kind of hard to come up with on this particular one. But yeah. Like I said, I'm rushing to make sure we get done. So on the next one. Like I said, this will be up. So when you have square roots, you don't want to do the square roots on your calculators. Because what will happen is it won't actually touch 0 when you're graphing it. It won't actually come down to 0. When you get really close, and it may actually be touching 0, but your calculator, because it's made up of little pixels when it graphs, can't graph the zeros on square roots with a crack. So it's really hard to do it. So what you do, square it. Square this one. Make it x to the 4th, x squared minus 2x minus 1. Graph that. Where this one is, where that 0 is where this one is 0. The zeros are in the same place. Okay? With this one, move that over to the other side, square it, and then combine them up together. So in this one here, the first thing you want to do is actually make it to x squared minus 4 equals x plus 7. Square that, and then set it equal to 0. And what I have here is I have both of them. The one in black is the original problem. The one in red is what I get after I square it. Same thing on this one. The one in black is the original problem. The one in red is what I got when I took this and squared it and set it equal to 0. Notice it crosses at the exact same places. Can we give you the worksheet here? Okay. So that's an important tip on that one.
It's easier to play games on these computers or on these calculators than it is to
Any questions so far? I know I kind of blew through these last ones pretty quick, but just make notes. I'll have the videos up so you can check them on them later. And it is. This today is all about practicing using your graphing calculator to find zeros. That's what this is about. Yeah, this is your homework. The worksheet's your homework. And then there is one more page. So to do this problem, okay, and like I said quickly because we're about out of time. To do this problem, you need to set it up. So a couple of the key things when you're reading this. According to the U.S. Department of Health and Human Services, the number Y of AIDS cases in thousands across the U.S. from 1982 to 1983 was approximately that where 0 corresponds to 1980. In what year did the number of cases reach 250,000? Not a problem. Take Y, replace it with 250. Why not 250,000? Because it's in thousands. 250 equals 3.223x squared minus 1.481x plus 17.75. Set it equal to 0 and graph it and solve it. There's a problem. Your graphing window will not give you all the answers. When you graph and you put it in the window, you will get 1, 0, which is negative 6.496. But that doesn't do any good because they're not going backwards in time. So your answer you're going to get, the one that's outside your window, you may have to change your window to get to this, 11.0918. Which means my answer would be that plus 1980, so it would be 1991 would be your